Okay, now let's look at the nnet library. Okay, so nnet library is used when we use caret. Caret will work for classification problems only with method equal to nnet, and neural net package is used for regression. That is, when the target is an interval target. So that's the reason why we have to look at nnet. And nnet, there is a limitation, and that is it can have only one hidden layer. You cannot have more than one hidden layer. Usually for most problems, one hidden layer is sufficient. You don't need more than one hidden layer. But if you do want more than one hidden layer, there are other libraries that we can use along with caret. But of course, if you don't want to run through various tuning parameters, how many layers, how many neurons, and what is the decay, and also on and on and on, then we don't have to use caret. We can use neural network, and that will allow you. If you don't use neural net within the context of caret, then you can use it for both classification and interval target. Okay, only when you are using caret for running through various parameter values and repeatedly running the neural net and trying to get the best fit, and in that case nnet is used for classification, neural net is used for interval target. So that's the reason why we need to understand nnet, and if you understand nnet, then you can understand more advanced network libraries that will allow more than one hidden layer. So nnet, remember, it can have only one hidden layer. Okay, so we're going to capture the object, network object, in say nn nnet. Okay, so nnet. Then we need to provide the formula, and the target has to be a factor. So we say as factor. Okay, so we're going to specify the data separately. So all we need to do is to specify the target, acceptance, and then we want to use salt and fat as the two predictors. Okay, and then we say data is df. Okay, and now we specify some parameters. So size is the parameter used for specifying number of neurons in the hidden layer. So let's say 3. And we can then specify parameters for updating the weights. So decay is the default value is 0. So we specify 5e minus 4, which means 0.0005. So a small this is for adjusting for weights, and maximum iteration is 100 is the default, so we'll use 200, and trace we're going to say false, and this will suppress any messages that are prints out. Okay, I have an extra parenthesis here. Let's see. Then there is a typo, so acceptance. Okay. Now if you use plot, okay, it's not going to work because the nnet function does not generate the information plot needs to plot the network. So we have to peel off what we need and then use plot net function from the neural net tools. Okay, so that's what we need. So and for that we need to use uh, we we need the nn.nnet. That is what is called WTS. Those are the weights. Okay, so let's put them in an object called weights, and then we need the number of we'll call that structure, the structure of the plot, stru, and that is in n. Okay, and these two will give you the what we need to plot, and then we do plot net. Okay, WTS and STRU. Okay. Okay, so there you have it. Now it looks a little bit different. So it doesn't give you the weights. Okay, instead it gives you the neurons, input neurons. There are two of them. Output neuron, there is one. So there is bias coming in, and the gray ones means the weights are negative. Blacks mean weights are positive, and the thicker the line, larger the weight. So that is how the weight information is coded in this. And we can change the colors. There are options for that. And we can specify what the names should be for the input and the output if you like. And for that you have to set up the names. So say input names. Okay, we'll call them input names. So input names are what? Salt and fat, and then output names is like. Okay, so then in the plot we'll specify x names equal to input names, y names equal to output names. Okay, so now we run that one, set up input names and set up output names, and then plot, and then you see the input names and the output names are printed in the plot.